Adrian. So essentially, I'm a software engineer at EDF Wholesale Market Services. So I've been with EDF for about 2.5 years, and I've been working kind of in various parts of the business as a DevOps engineer, data scientist, and all that jazz. I joined in through the grad scheme actually, so I was able to do quite a few of those rotations. So at the moment, I'm a part of something called Wholesale Market Services. So I'll expand a bit more about what that is in a second. And I'm a part of something called the Run service, which is essentially software engineers and people who support how all the services within WMS. So I'm just going to start off with a brief intro into wholesale markets. So this presentation will essentially be really high level. So it will give you kind of an introduction, a bit of a taster of what we do with data. So if there's anything specific that you want to ask me and I can't answer it on the spot later in the Q&A, then you feel free to email me and I'll always be able to get back to you at another time. So just an introduction into the wholesale market. I'm going to draw your attention to the left side here, where we've got a chart of demand and generation. So this here is actually National Grid's forecast of demand and generation. And for those of you who don't know, National Grid is responsible for the distribution of energy to our customers. They pretty much worry about keeping our lights on. And you know, the essential building blocks of a market, you got supply and demand. So in an ideal world and in an ideal scenario, we actually want to keep demand and generation to be zero, because if that doesn't happen, then you'll get your blackouts, you get transmission lines burning, and or bad things happen basically. So we always want to keep that imbalance, we call it, to be a net zero. And if you look at this chart here on the right, as demand increases, you know, you've got the peak times, then you've got more generators having to come up. So that could be nuclear power plants, gas power plants, and these get more and more expensive. So then you've got a price point. So as demand increases, price in the market also increases. So you've essentially got the basic building blocks of a market. You've got supply, demand, and price. And this is where we come in. We provide that energy to our customers by operating in those markets. So just on that diagram on the left here, so I showed you here generators and suppliers. So we as EDF, as a supplier, we're responsible of getting you that energy from the wholesale market. So that's pretty much the core principle of WMS. I'm sure we've got assets, our own assets that generate electricity, but the traders will have to sell the output of those assets. And it tends to be that we sell it internally anyway to our own supply, but at a fair market price. So that's essentially at the core of what we do at EDF WMS. We operate at those wholesale markets. Now, energy can be bought at pound megawatt per hour in the wholesale market. That could either be through market exchanges such as Nord Pool and EPEX Spot, or they could be through direct buyers and sellers through bilateral contracts or over the counter. So this is just giving you a brief introduction of how the market works. And something to note with energy is how we buy and sell, and how much of that into the future we buy and sell. So it can pretty much be sold up until the point of delivery. And sometimes we make this distinction between baseload and adding shape. The baseload is essentially, well, energy that spans the whole day. It's a lot of the bilateral contracts actually are baseload trades. That's energy for the whole day. But as we get closer towards the days, we want to add more shape so we get that energy to meet demand. So it's a bit more looking like the previous slide that we showed earlier with supply and demand. And this depiction here on the right kind of shows where at the time scale that those kind of happen. So in the beginning, you know, before up until 1 hour of the actual delivery, we have a wholesale trading period where we trade on the wholesale market. Everything's a lot cheaper. We can trade in months and years in advance. And when we get to gate closure, 1 hour before, National Grid tries to essentially balance the system a bit more by telling participants to flex up or flex down, i.e. generate or decrease generation. And And following that, it's a period called NIV chasing, but I'll explain a little bit more about what NIV is. It's actually, it stands for net imbalance volume, when I deep dive into one of the tools that we've got. That's essentially an introduction, a little bit of an introduction onto the energy market. So you can see it's a little bit more, it's comparable to some of the existing markets that you probably already know, such as the stock market, with various differences. So our structure within WMS, we've got a few parts of the business. So for example, we've got commercial. Commercial is pretty much responsible for the customer facing side of things, contracts. They look after our assets, they manage our assets. Then we've got portfolio operations. They have, for example, volume forecasters here who essentially predict the forecast of the demand. You know, when you turn your kettle on, that'll get pretty much implemented into our forecasting systems, or the short-term traders who trade energy in the short term, or they look after and optimize their flexible assets. And this is where I reside in the technology and operational integrity. So we're basically the support for the three other areas. So that could be anything to do from IT to a change strategy to data. I'm a part of this area called the run service, and I'm a software engineer that reside in there. That's a brief overview of the structure within WMS. So why is data so important in the energy market? If we look at this chart here on the top left, we've got volatility. So this is the electricity prices, the day ahead prices, so prices in the day ahead. And it's a monthly average that shows how many years? About 10 years in the past. And you can see that pre-2021, things were kind of predictable. We can forecast that. It's quite, it was good, easy for us to forecast. And then now 2021 with the energy crisis, the price volatility has been insane. And this is just a monthly average. So it really doesn't really show the fluctuations and volatility. And we have to take that into account. And we don't bake in, say, 25% margins into our contracts. It's more like 3%. So we'd have to manage our risk really smartly and take in all this data. We've also got we also have to look after our customers. You know, as EDF, we have to be as customer centric as possible. So we need to try and keep those prices down as much as we can. So it's just ever more so important for data. Um, well, for us to process that data and manage risk as well. On top of that, the media, I'm sure you've seen in the news all the time, we're always being scrutinized on every action that we take. So again, it's just so important for us to manage this data. And we've got lots and lots of data, be it asset data, generator data, demand data, weather data, the non-energy costs like the transmission line costs that gets you the electricity from A to B. There's just so much data that we have to take into account in order to function as a business. So I'm going to give you a couple case studies to kind of give like an overall summary so that you understand some case studies in the business. So for example, we've got a team, the team's called Cosstack, and just having a look at some of the flows. We've got market analysis, they're also another team, and volume forecasters, they're another team. The market analysis, for example, provides price predictions. We call them forward curve predictions. And volume forecasters, they produce demand forecasts. And Cosstack also takes in costs such as the non-energy costs. So this is your transmission network system costs. Again, like I said earlier, A to B, environmental tax. And you'd be surprised, there's actually quite a lot of costs that actually stack up, right? Cosstack. And they actually run all this data through an on-prem Python application called Costbase, which runs every day on a daily basis and passes on that cost stack to the sales and marketing pricing team, which is then what you'll see if you are an EDF customer in your bill. It all gets fed in as a part of your bill in the pricing tariff. Another case study, you know, National Grid Turndown Service. So this is a part of our net zero initiative as well. So we've got customers where, you know, during peak demand, we want customers to turn down electricity, and they get a reward based on that. So, for example, our customers will then have to sign up to that, and sign up to this national grid turn down service. National grid will tell us that they need to turn down, and we submit a bid based on the forecast that we have with all the data from all the customers who have signed up. If we win that bid, then 24 hours before we'll have to notify the customer, say, hey, please could you turn down in the next 24 hours, and the customers turn down, and we actually have data science teams who take in that data from the customers, from their half hourly data from your smart meters, and then we'll see whether or not those customers have turned down during those times, and they usually get a reward out of it. So those are just a couple of case studies of how we use data within WMS. So I'm gonna take a step back into kind of an overall element of data, because I also look after a little bit of the data strategy within WMS, and I won't be reading through all these bullet points, but kind of in a nutshell, our strengths within WMS is we've got really good market experts in the market who can pretty much predict. So, for example, we've got a volume forecasting algorithm, and one of our market experts will see that National Rail is going on strike, and that person will know exactly what to do. They'll know exactly how to factor that into our forecast so that we can better position ourselves in the market. So our algorithms and the people is where the strength lies in how we forecast those trades and what our position. We've also got all the data we need, and we've got really capable developers who create these amazing modern applications, be it serverless applications, or we might have some on-prem applications, but we're moving towards a modernization strategy in creating these serverless applications. So if you think about challenges and opportunities, I'd say the two biggest ones are modernization and of course the volatile markets that we've got at the moment. So kind of to overcome challenges like this, we follow the data pillars. So everything has to be business led. So every time we involve the senior leadership team, every time we involve all the stakeholders, every single reason why we're going to do something, it's going to have to be business led. And underneath all that follows the typical data strategy elements of a data strategy. You've got a unified architecture, governance, ways of working. So all those elements that you would find in a typical data strategy. So giving you a more of an overall view of say those pillars implemented in an architecture, so you can kind of visualize what goes on within our systems. So we've got a lot of data that some of that data still on legacy systems that we're planning to migrate, or at least we're chipping away on those migrations to modernize a bit more. We've got all these databases. They tend to be OLTPs or databases where our applications are relying on, because that's what we are. We're mostly an operational part of the business where we need to rely on data that's operational. So, for example, overnight batch runs aren't going to cut it for us when we don't need this massive OL analytics database where we have overnight batch runs. Sure, we'll need that for other teams, with internal users that focus on analytics and data science, but a lot of our applications and business decisions need to be made today. If you ever walk into our office, you'll see a bunch of the traders in there making decisions every split second. You'll have alarms blaring, telling the traders different elements based on their tools. So like I said earlier, developers, we develop the applications, and that data is accessed through various ways, whatever interface that may be. We apply appropriate data governance, and our internal users may be utilizing that data as well in the same way. We also have a customer data lake, which is hosted on Snowflake, but that's more for the rest of the business at the moment. So we're planning to have a bit more data sharing between the customer's data lake. That should give you a good overview of what we have within WMS in terms of like an overall strategy. So I'm going to deep dive a little bit into one of the tools that we've got, the net imbalance volume tool. So net imbalance volume is essentially the volume of an overall system energy imbalance. So remember when I said imbalance being the difference between generation and supply, and we want that imbalance. We don't want that imbalance. We want generation to equate supply. So this is a net of all that system and also the actions that have been taken to balance the system. So it's a net imbalance volume of energy after all the actions to curb that imbalance have already been taken. So this application is essentially a serverless application. It's hosted on AWS, and that's a little screenshot of the application itself. So to give you a bit of context of what this application is, like I said, you need to get your imbalance right. So number one, National Grid, they're responsible for keeping the system balanced, right? They want demand to equal generation. And as a supplier, we're responsible for keeping it balanced for our customers. So um, supply and EDF customers, we need to keep that balanced. Because if we are the cause of that imbalance, or according to National Grid, then you will have to pay a penalty price. Then it's the trader's job to make sure we are balanced, to see whether or not we're long. So long meaning we're over-generating, we're about to over-generate, or short, we're under-supplying. They kind of have to weigh in the options to see whether or not, okay, do we need to buy more energy now in the wholesale markets, which is much cheaper, or risk a penalty price later? And we can't really trust National Grid's demand and generation forecast because generators sometimes oversupply and undersupply. Just to give some context, for example, the blue line is actually something called physical notifications, where generators actually have to notify National Grid of what they're going to supply. And a lot of the time, sometimes oversupply, undersupply, or generator might trip. There's all manner of things happen. So we have to forecast our own imbalance, our own demand, our own net imbalance volume, and we've got a few algorithms to do that. And the traders, they operate 24/7, so this all needs to be real time. We need to provide an absolute real time view for this, and we do that through NIV tool. So there are quite a few functionalities of the tool. I mean, there's a net imbalance volume sheet that gives you a live view of the net imbalance volume and the forecasted demand from National Grid and our forecasted demand, which I'll show in a second. There are various other screens like interconnectors, the flows of electricity between the countries, tracking the wind, tracking your demand. But the point is we're trying to get this at a 24/7 live view for the traders. So that's the main objective of what we're trying to show here. And this is just this is the net imbalance volume sheet. So just in case there are some competitors on this call, I have conveniently blurred out some certain elements on here so that nothing can be inferred in how we calculate our, say, predictions and whether or not the market's going to be short. So just a good, so for example, here we've got the cash out price, which is essentially another word for penalty price. But the part that I want to bring out is, for example, this bit here where we've got the percentage of short probability, where we actually had the R&D team have a look at the past 3 years of data and then pretty much create a probability matrix. So then we'd always have our live data pass and match that probability matrix and pass back a probability so that the traders can see is the system going to be short in the future or not? And that's really key in their decision making. Yes, we've got our own net imbalance volume forecasts and various other bits that I've blurred out. So this here is the tool's architecture. For those of you who know AWS, it's really an application. It relies on the one API, so it's quite simple. It's not got too many functionalities apart from just getting the data onto the screen. So I have multiple people. They'll access the application. It'll query the API, which will then activate Lambda and essentially get data from what we store in a DynamoDB table on AWS. Among other things, this is where the percentage short step happens. So live data is applied to that series of probability. We've also got various data sources and APIs, and and elements, and we just bring that all up to a screen so that the traders can monitor on a real-time basis. We also have we also use data from a market database, which I thought it'd be good to mention that there was a massive migration effort, basically to move this market data from a legacy on-prem data source onto AWS Aurora, and it functions beautifully now. So that's one of the elements just on the back of what this tool has. So overall, but going back to the pillars, we've modernized by creating a serverless application for the traders. We've focused it on a business-led opportunity for the traders. It's very important for the traders to predict the market, and we focus on governance and architecture, a way of working, and we adopt an ownership model. So people are pretty much good at what they do. So then they own the tool, they develop the tool themselves, but all these parts of some tools, for example, we give full ownership to different teams and we train them on Python, for example, so that they'd be able to have ownership of that tool and develop those tools. And it's worked out really well in that sense, because then we get to chip away, get away from legacy systems, build new things, and have resources focused on specific needs of the business. So that pretty much concludes my presentation. I've just got a couple more slides, just kind of to give you a bit of information, because this is all kind of high level, so I probably won't be able to answer some really specific questions. But here's just a couple of QR codes if you want to get in contact with me in the future. And we do have a few career opportunities at EDF, which you can get from that second QR code there. So with that, I'm just gonna hop onto the next screen. I don't know if Dave, you might want to hop back later on this one. But I just wanted to kind of just say we're going to move on to Gustavo now, who is the lead data scientist in R&D. And we're going to think a bit smaller. So we thought about the big energy markets, how we get energy to you as a customer. But now we're going to think about our energy assets and how we use kind of machine learning, and got a little bit of a hint there because we've got a small drone having a look at some renewables. But yeah, that's pretty much it from me.